All right, welcome to this talk. As you can see, the title of this talk is Briefing on the Modern ML Stack with R, which means that we're going to talk a lot about R, and by modern we mean whatever is cool and awesome that we hear on the Spark Summit, which are things like Spark, MLflow, and TensorFlow. So as a quick overview, for those of you, I'm assuming that most of you are familiar with R, but in case, unlikely in case that you're in this talk and you don't know what R is about, this is your 1 minute overview of R and why it's interesting, or at least for me. And like if we start with what is a data scientist, I think the closest that I found to a definition of a data scientist is this very popular tweet from Josh Willis, which says that it's a person who is better at statistics than any software engineer and better at software engineering than any statistician. And if you look at the definition of what R is, if you go to the download page for the R programming language, what you will see there is it says that R is a programming language and free software environment for statistical computing and graphics. So, you get the idea. Like it was a programming language that was designed with statistics in mind, and that a lot of people have been using in combination with statistics since then. And it's actually a bit more than that. Like what this diagram on the bottom left side is showing is a diagram from Rick Becker, who presented it on Use R 2016. And basically it shows that R was intended to be from the very beginning what they called an interface language. So it was supposed to be a language that makes your life easier, and it allows you to interface you with multiple systems. One of those systems could be Spark or Python or TensorFlow, and why not? And the chart on the bottom right is basically showing the number of cron downloads that have happened since 2014 in millions. And as you can see, the R community and the R package community is pretty vibrant and has been growing since then. So that kind of explains why R is interesting for me and in general for data science. And within R, there's even what I like to call this concept of modern R. And modern R just basically means using relevant and modern R packages. And there's a lot of R packages that have been developed in the recent years. One of them that is going to be relevant to this talk is what we call in the R community the tidyverse. And the tidyverse is comprised by multiple packages, but the most prominent ones in there are dplyr and ggplot2, which you might have heard of. And just to give you a sense of how this looks like, if you look at tidyverse code, this would be basically code that actually works and that we're going to use during a demo. And basically what it does is you import the libraries tidyverse, and in this case a data set, and then you're basically doing some data analysis with dplyr, which allows you to group by and then summarize and do some filtering. I would need a little bit more time to explain why this is also kind of like in many cases better than SQL. It's mostly more concise, and why not? But we won't talk too much about that. But in general, just think about it as R and their libraries and packages as like a big ecosystem of interesting stuff that is out there. Just a little bit about myself and RStudio. RStudio is a company that was founded to help basically develop tools around the R language. It was founded in 2009 by JJ Allaire, and one of our first products is the RStudio IDE, which is basically an integrated development environment that you might have heard of, kind of like PyCharm, for instance, when using Python. Shiny is a web framework with reactive technologies that, again, was created in 2012 and been growing since then. And the tidyverse by itself got coined in 2015, even though some of the packages were already being developed. We started our work with helping Spark and the Spark community in 2016. And later on in 2017 and 2018, we've been working with also TensorFlow and the MLflow project, which some of you are also familiar with. Now, not everyone in RStudio works in Spark, TensorFlow, and MLflow. This is our team. We call ourselves the multiverse team. You figure. And we mostly work on Spark, TensorFlow, and MLflow and similar technologies. We have 4 members currently. Daniel, he's based in Brazil. Sigrid, she's in Munich. Kevin, who is in Seattle, like myself, Javier. All right, so that was a very high-level overview. And this talk, we're going to talk mostly about packages and technologies that are relevant to Spark AI Summit. As I mentioned, like we don't work directly, our team, in the tidyverse, but it's pretty relevant. I'll explain in a second why. And we'll talk about Spark, which we started development in 2016, TensorFlow, MLflow, and more recently, Arrow is actually a pretty, it's the project started before 2019, but a significant investment from R and the R community started around 2019, and I'll mention that it is available now on CRAN, which is our package manager similar to Pip and Conda. All right, so we'll start with Spark and kind of like mention what's there and kind of like what are the newest developments. We won't have time to kind of like explain exactly what is Spark, obviously, or how to use Spark with R. Mostly we're going to focus this talk on what are the new developments. But if you want to catch up with these things, we've been in previous Spark summits, so you can watch those talks or just look for online resources. But just to give you again another 1-minute introduction to Spark with in R. Well, first of all, I'm going to recommend you use the package SparklyR. And just to give you an idea of why, what was the motivation of creating SparklyR and why it's great when using Spark in general, you can think of SparklyR in some ways as koalas from the Spark community, where in a sense you have some R code that already uses some of the packages from the tidyverse, in this case dplyr, and if we run this code, it would just work just fine. What we want to do with SparklyR, which is our interface to use Spark in R, is mostly to try to leave the code as unchanged as possible, such that you can continue using the packages from the tidyverse without having to modify all your code. So this is kind of how the code looks like. You basically import the library SparklyR, and then, well, in this case, we still need the data set. You connect to Spark. You need to choose if you want to use Spark locally, or if you have a Yarn cluster, Meso, a Spark cluster in standalone mode, a Livy connection, or if you're using Databricks or Qubole, or why not, you pass a parameter method equals, then Databricks, and then everything just works. So mostly you need to connect, and then you need to load your data set. You either need to load your data set using the Spark APIs, or in this case, since the data set is small, you can just copy it to Spark. So you're saying copy into Spark the flights data sets, and that's it. And then if you run the code below, like the code below will execute and will just run. The only difference is that it's no longer running in R, it's running in Spark, which is it's what you want. Now, to be fair, this is ongoing work. There's other things that you might have to tweak and change. If you use Spark, for instance, if you have to use machine learning algorithms and you're used to packages like Caret or Parsnip. Actually, Parsnip already supports Spark, but like in general, you would use the machine learning APIs from SparklyR that Spark defines, not exactly the ones from R. But we're definitely looking towards, like maybe on the next few years to make it even more streamlined. And even if you're doing modeling in R, we wanted to make it as straightforward as possible for you to move to Spark when needed. This is a bit of the timeline, and again, there's a lot of content to present in a single talk. But we started working, as I mentioned, in 2016. We started with with the basic interface to Apache Spark and simple things that you would expect, like installing Spark, connecting to Spark, copying data to Spark, reading data. You get it, just the basic stuff. Then the next point release was SparklyR 05, where we added support for Livy and some dplyr improvements. Livy, basically, it's this Apache project that has a monopoly on providing a web interface into Spark as an API. So, it's the package that kind of like works, and, it's the one available that you can also use with SparklyR. And SparklyR 06, we added support for defining arbitrary distributed R code. Is this still working? I bet so, right? Yeah. Anyway. Yeah, basically, SparklyR 06 has support for distributed R codes. Basically, that means that you can define your own mapping functions when you transform R code or R data frame, Spark data frame using R code. You can basically use arbitrary transformations. And then in SparklyR 07, we added support for Spark pipelines. So what is a Spark pipeline? If you're familiar already with Spark, it's basically this abstraction that lets you define transformation and modeling on kind of like a higher level. What that allows you is, if you're working on a team with data scientists that are using both R and Python and Scala and why not, you can basically define, if you're used to using R, you can define a pipeline in R, and then you can export that pipeline as a Spark pipeline, and then you can load it in Python and why not. So it's kind of like really useful when you're kind of like working with teams with multiple data scientists. Sparkly ROI, we kind of extended this concept and added support for pipelines in production. Basically, this means we integrated the MLeap project. And what this project does, it allows you to take a Spark pipeline and make it agnostic to Spark and executable in any Java-enabled runtime. So basically, that means that if you have a web application, and you want to run, the same model that you create on Spark, like you can run it in a web application or in a mobile application using MLeap, as long as it supports Java, right? That's a requirement. And Sparkly Arrow 9 adds support for Spark structured streams and Kubernetes. And Sparkly Arrow 1, there were a bunch of extensions being added, and also we integrated with Apache Arrow, mostly to improve the performance of these distributed R transformations. And last but not least, we've been working on a book. It's called Mastering Spark with R. And I'll give you a preview. I'm not sure if the microphone is working. I'm skeptic. It is working? All right. I think they just tuned down the volume because it's good. Anyway, so this is the book. It's called Mastering Spark with R. Matei was very kind enough to write us a foreword. So if you want to get it and you want to get up to speed on how to use Spark with R, it should be on sale like in a couple weeks. All right, so that kind of like hopefully get you up to speed in, from the last 3 years on what we've been doing on Spark. These few slides will cut you up with the things that have happened on the last few months. So we added support for Apache Arrow. Apache Arrow is this Apache project that allows you to share memory across the memory layout across different systems. You don't need to know the technicalities, or if you want to, you can. But basically what it does, it makes the distributed R transformation and some of the collection of data and copying of data faster. So this chart is basically showing what's the time it's taking us to transform data with a Spark apply. I don't remember how many rows there are. I think in the left side there were, it's 100,000 rows on the left side and 1 million rows on the right side. And you can see that there's almost 2 orders of magnitude speed up using Apache Arrow. And now these metrics were taken with my local, like MacBook Pro. And I didn't even add more memory to Spark, so this is like the bare minimum that you can get, but it's kind of nice because you can see still like a huge improvements. Obviously, you can scale to more data without even using Arrow, but that requires either that you configure Spark to use more machines, or it requires you to get more machines. There's also a new extension in the Spark and R world for XGBOOST. So if you're familiar with XGBOOST, it's this very popular modeling library that won or became popular from winning one of the Higgs boson competitions in Kaggle. So it's just very popular to use it with small data sets that fit in your local environment. But you can also now use it with Spark. You basically add the library Spark XGB, and then you copy the data as usual, and then you would basically run the XGBOOST classifier, which is using XGBOOST to fit the model. And the interesting thing here is that, again, is fitting the model using Spark and using the XGBOOST Spark library, but it's kind of like straightforward on your end. Another popular library in the R community is what is called Broom. And basically, this library allows you to convert the parameters from a model into a data frame. Which, it's kind of like really useful because if you're fitting multiple models and you need to keep track of them, at some point you want to kind of like have the same interface to all of them. And basically that's what the package does for the R packages that provide modeling functionality. So with Spark models, you can get a similar also experience by converting, in this case, we're using Spark's MLALS model. And then we're calling augment, which basically adds the prediction. But you could also use Broom to extract the parameters of the model and have them on what we call a tidy data table. And this is kind of like a nice transitioning slide to also TensorFlow, because one of the things that we've been noticing in the past few months is that While TensorFlow was its own thing for a few years, like you would usually do Spark for big data, and then you would do deep learning related stuff with TensorFlow, and they were like their own separate worlds. It is becoming more common to also try to use either TensorFlow in a distributed environment or just getting data from Spark and passing it to TensorFlow. So one of the libraries that you can use from R to help you do this transformation of data from Spark into TensorFlow is called TF records. And basically what that does, it allows you to write TF records from Spark in Spark such that when you collect the data, you can run it on a single GPU using TensorFlow without having to load CSV files or whatnot. A lot of the times we have unstructured data in Spark, and Spark is great for transforming those big data sets in many ways. One of the ways that you can transform them is from big unstructured data, you can transform it to numerical data sets. And once you have it into, like down to a few hundred megabytes or gigabytes, then you can write all that data out as a TF record and then read it on TensorFlow and work with it on a single GPU or why not. Actually, yeah, there's a couple other things to mention. Extensions that are being developed. There's one extension called VARIANTSPARK, which mostly it's an interface to the VARIANTSPARK project. I'm not an expert on bioinformatics, but basically what this extension does, it allows you to do importance analysis. I don't know if does anyone do genomic analysis here? Maybe not. Anyways, so and there's another one on the genomic space called SparkHale, and there's a big project on Spark called Hale. It's the Hale project, and mostly what this project is doing is again providing functionality that for doing genomic analysis on Spark, which in this case you can also start using from R when using Spark. Another kind of announcement is that we created a new organization on GitHub with all the extensions. I think currently we have over 20 different extensions from using Spark with R. Doesn't change much apart from making it much more discoverable. So you can go to this GitHub organization called r-spark and mostly take a look at all of them. And if you're working on an extension for Spark and R, definitely let us know because we would love to add it. The idea is mostly to help people's extensions gain some visibility, and also like if there's opportunity for the broader community to help with your extension, it's good to have them on a single repo. Some of the things that we're starting to work on that are not even ready to be tried. We're creating an extension for SparkNLP, and by we I don't mean us or RStudio, but mostly like the R community in general, the R and Spark communities. And this extension will allow you to interface with SparkNLP, which is one of the state-of-the-art natural language processing frameworks. If you want to try it out, you might be able to. Just let me know and I'll help. All right, so moving on to TensorFlow. Again, I'm not going to present what TensorFlow is. I'm sure like you've all heard about it, but think about TensorFlow with deep learning. And this has been the timeline of embracing TensorFlow in the R space for the R community. As I mentioned, it all started in 2017 with the initial release of TensorFlow by itself. And we pretty quickly realized that TensorFlow is pretty amazing, but it's also pretty hard to use on itself. There is a library called Keras, which the initial goal of the Keras library was, I believe the motto was something like deep learning for humans, and kind of like speaking a little bit on kind of like the difficulty of embracing TensorFlow by itself. So if you haven't heard about TensorFlow or are looking into playing with TensorFlow, I would actually recommend that you don't start directly with TensorFlow, but you start with Keras, which is a library that supports multiple deep learning frameworks, and as one of the frameworks that it also supports is TensorFlow. So that was released somewhere around July 2017. And then a few other libraries got released. TF estimators, which basically allows you to use GPUs and kind of like deep learning approaches with kind of like more plain vanilla modeling, like linear regressions, GLMs, and why not. The state of the art of that package, I think. I honestly, I haven't seen a lot of development on general on TF estimators. I don't know what's the future for that particular library, but then somewhere in 2018, we also added support for TFDATASETS, which is another sub-project on the TensorFlow family. And what TFDATASETS allows you is to pre-process data easily. So if you think about it, like when you're doing deep learning, a lot of the computations happen, or we try to make them happen in a GPU because the GPU is more efficient on this type of deep learning algorithms. But the problem is also getting the data into a GPU could be a tricky process because at the end we all have our data in CSVs or like Parquet files or in Spark or whatever. So basically TFDATASETS, what this package allows you to do is transform the data sets also in the GPU and gives you some helper functions to load the data easily into TensorFlow. And JJ wrote a book with Francois Cholet, who is the creator of Keras in 2008. If you're looking into learning at how to use TensorFlow or Keras, actually Keras, from R, like I would recommend that book. It's called Deep Learning for R. CloudML was a little package that we developed to allow you to train TensorFlow models in Google Cloud Compute instance. So, like at the time when we were working on this, it was pretty tricky to get a hold on a GPU. And I think that's still the case. I mean, I don't have a GPU on my own. And what I end up doing is usually I get a cloud machine with GPU, or I use CloudML to mostly upload the models up to CloudML. And once you have the models running there, automatically they can get trained with GPUs, and then you get the results back. TensorFlow Eager Execution got added on August 2018, which was also around the same time where we added it on the R TensorFlow package. And most recently, the team has been working on TF Probability, which it's, I actually mentioned a little bit more about TF Probability, but it's also quite a new package on the TensorFlow world. So I mentioned what's new. Well, TFDATASETS, we kind of already explained what it is, but here's a concrete example. So in this case, what we have is some data, which is our training data. Then we're deselecting the ID, for whatever reason. But the interesting thing is that, like at some point you want to convert the columns that might have been categorical variables, or why not, you want to convert them to numerical values. And we have like a bunch of different helper functions to easily help you convert those columns to something that is a tensor that TensorFlow can understand. And again, this is probably a lot for a single talk, but if you're thinking of loading data, just think of TFDATASETS when using TensorFlow in R. TF Probability. The interesting thing about TF Probability is that allows you to add probabilistic models to your deep learning models. So to me, like the easiest way of explaining this is, if you're looking at the MNIST dataset, which is just the standard kind of like hello world example on TensorFlow, it's mostly, the task from the MNIST dataset is to classify a set of digits that are created out of, just images. And like when you look at MNIST and you classify MNIST, you usually have an output layer, and the output layer has numbers 0 to 9, right? So whenever like the neural network detects a 0, like the last neuron with output 0, that is related to 0 has a positive value, and that's it. So kind of like the challenge with that type of model is that you don't have any estimate of the probabilities, right? It's either a 0 or a 1, or or a 9 or an 8, but you don't have a sense of like, how certain are you of this being classified as a particular number. So kind of like a lot of the complement and motivation of using TF Probability in the deep learning space is to help you assign probabilities, such that when you classify numbers, just to take an example, or some other images or some other processes, such that you can also assign probabilities and say, well, I know that this might be a 0 or a 3, and the probabilities as assigned with this is like 40% and 60%, or why not? And also it gives you the actual probability distribution, it's quite nice. And most of the work on the last couple of months has been around TensorFlow 2.0. For those of you that are following or closely following what's going on TensorFlow, this was a post from September 30th, which I think was the day when they made it officially available, the TensorFlow 2.0 version. And we also made it available a couple of weeks afterwards on CRAN. So if you want to use TensorFlow 2.0 with R, just get the latest version from CRAN, and that should work out quite nice as well. And again, we're following the same pattern of creating orgs for all the extensions and trying to move most of our packages to organizations that are agnostic to RStudio. And we created a new GitHub organization called r-TensorFlow. And it's not as active yet as the Spark one. Has probably around 4 or 5 models. But the idea is, like, if you're working with R and TensorFlow and want to contribute, let us know, because we would love to have your extension there and just kind of like help it support it, and why not? Just to pick one of the models, for instance, we added support for a model called, well, it's called GPT-2, which is OpenAI model for text generation that got quite some press earlier in the year. And what is really cool, I think, about R in general and using R with TensorFlow is that it's actually quite easy to get you started. So if you want to use this model to generate fake news about Spark Summit, why not? So what you can do is you want to install from GitHub this particular extension, and then you want to install the dependencies from this extension, which install GPT-2, and then you want to transform or complete, a fake news based on a headline. So the prompt that you give to the package is GPT-2, and then the prompt. There's a few parameters that the GPT-2 model takes, which I'm not an expert in, but basically in this case, what it's generating is the Spark Summit Europe conference will begin this weekend. Okay, that's pretty great. It will be held in the United States and Hong Kong, where Spokane Organic GM store and electric cigarettes store will be featured. Okay, that's interesting. But as you can see, like the actual generation, like the text generation is pretty nice. The workshop will contain a South African producer, distributor, and a company field visit. All right, so anyways. So I think the point here is that it's pretty easy to use TensorFlow with R, and to me, this kind of like also describes why am I excited from using R with TensorFlow and Spark and MLflow, and mostly is because the interfaces end up being quite more friendlier and easier to use. I think some of the trade-off is that you might not get the state of the art, or you might be behind a couple months, but I think it's a fair trade-off for ease of use and simplicity when using R. And kind of like looking in the future, we're starting to experiment with how to do TensorFlow this in a distributed fashion. I know that a lot of times a GPU is not enough. For those cases, you can use CloudML, which is a great way of parallelizing your computation. But also, Spark and we all being here at Spark Summit would make sense also to easily help you parallelize deep learning workflows in TensorFlow. I'm sure there's a way of getting it done today, but it's probably a bit painful. We want to make it really easy such that next time that you need to train something, even if you don't have a GPU, you should be able to use Spark and use the cluster that you already have for a different purpose. All right, so MLflow. Again, I'm not going to mention what MLflow is. We're going to have a keynote apparently tomorrow, which is great. But what's happening in that space? Well, one of the things that are most exciting to me is, like, if you want to use R with MLflow, from the very beginning, since the project started, we work with Matej and his team to implement a version that supports R from the very beginning. With TensorFlow and Spark, we were kind of like a little bit late to the party. With MLflow, we're just right there in, and they're doing a great job, so definitely recommend also using MLflow. So the way to start is you go to mlflow.org, that's pretty much it. You go to the docs, you go to, in this case, the quick start, and mostly there's like a toggle button there between Python and R. If you want to see the Python code, just click Python. If you want to see the R code, you would get this, which is basically install packages MLflow, and then install MLflow, and once you have those two, you're up and running and ready for business. And again, this first release for MLflow was in CRAN on 2019 on October. Matej, he's the current maintainer and author, and yeah, it's going great. Like, there has been releases, constant releases at a par with the Python version. So my guess is that the latest one is 1.2. Hopefully 1.3. The old versions are on the right side. And whenever there's a new feature on MLflow in general, on the Python API or Java API, like it's being ported to R. So you have like a pretty good certainty that you can use both together. And again, I didn't mention what MLflow is, but think about it. Because in 30 seconds, I would explain MLflow. If you have a lot of models that you're already producing in your organization, it's usually a bit of a pain to actually manage them and figure out who trained what, with which data, and how to retrain them and how to deploy them. So if you have those type of problems, you can consider using, MLflow. And again, if you're not a Spark user nor TensorFlow user, but you do use R for modeling, and like you live in an organization which with a bunch of data scientists working in R and you have a lot of models, you can also consider using MLflow as a way of sharing and giving more visibility to the results that you're producing in your organization. And few developments that we're thinking on the MLflow space for R. One is using the new RMF package, which is going to be a replacement to Packrat for those of you that know about its existence. And we're also planning to add support for cloud deployment targets. So basically being able to deploy an R model directly from R into AWS or Google Cloud or why not. And Keras Autolog, basically if you're using Keras, currently the Keras package for deep learning, currently you need to manually log the metrics of your models. We want to make it easier for you to, once you use the Keras libraries, it will log automatically the state of your models and your metrics directly into MLflow without you having to write additional code. All right, so with that, I'm going to try to do a quick demo. I think we have time for a demo. Mostly showcasing kind of like all of these working together. And it's less, there's less specifics on the demo, and there's more about kind of like talking or showing you different ways in which you can use the four of them together. Apache Spark, MLflow, TensorFlow, and Arrow. So one of the ways that you could think about tackling these type of problems is basically by using Databricks. So one of the good news is that Databricks added support for sparkly-R. So whenever you create a new Databricks cluster by default, if I understand correctly, but make sure you read their docs. Basically by default it installs sparkly-R, so you can just run sparkly-R code, connect to Spark, and use all the libraries, the functionalities that the library provides. But for a specific example, let's just do that. I'm going to run this code, this has nothing to do with Spark. It's mostly tidyverse code, and hopefully my cluster is still running. I think it should. Maybe not. Yeah, it's green, right? Yeah, so I might have gone to sleep, or why not? But basically the idea is, here I'm running some code, which is just plain R code based on the tidyverse, and is executing. And basically when you see after this finishes is that it completes executing, and that's pretty much it. Nothing super interesting there. Interesting. Oh, you know what? I might have to, this was actually my fault. So I rerun this before the demo to make sure the demo works, but that actually broke the demo, yay. Anyways, so in this case, what we're doing is, we're just running plain R code. You have the results here. Well, how does this look like in Spark? What you want to do is, as I mentioned, run these two lines. What these lines are doing is basically connecting, same thing. Let me just add this reference, because I overwrote it. All right, we'll give it another shot. Mostly what this is doing is connecting to Spark, and you can see here that the method is Databricks, and then it's copying the data from your local R session into Spark. And again, usually you don't have to copy data. Like if you have large data sets, they already live in Spark, so you actually read them. You don't have to actually copy them. And then if we were to copy paste this exact same code that we have up here, and just rerun it, or I guess we could rerun the same thing again. So if we were to rerun this exact same code, basically what would happen is that, did it finish executing? Yeah. What we would see here is that when you execute this code, it's similar output, but it just happens to be running in Spark. And actually, this is not Spark, because I need to remove this. This is still the old one. But if we basically use that data frame that we copied into Spark, which is the flights table, and we execute it, what you would see is that the source is Spark, and basically just execute the code in Spark, which is really useful. And in a similar way, you can also use MLflow. For instance, in this case, we can run, after you install MLflow, you can run some parameters. And you can see here that MLflow is also integrated on the Databricks Community Edition. So you can make use directly of TensorFlow here. Now, if you're not using Databricks, one of the projects that I've been working on is it's mostly making all these libraries on a single Docker image. I'll give you the resource, but it's mostly a Docker image that allows you to like install all these packages and technologies together in a single image. And you can use it with Docker if you're familiar with Docker. You can use it with my Binder service, which basically what Binder does is it allows you to run data science notebooks for free. I believe Google and someone else sponsors them. So all you have to do in your repo is add this batch, and basically what that gives you is it gives you it prepares an environment for you to use, just to save you a couple seconds. Like basically this is the my binder environment that you get. By default, they default to, oh, this one is already gone, so we would have to wait a few seconds. But you can also open, like an RStudio session and execute it. Similar with Paperspace. Paperspace just announced that you can get free GPUs for data science purposes up to 6 hours. So it's another a great way of trying to use this particular technology. So you can just mostly launch the Docker image in their service, and what you would get would be you would get this Jupyter session. You can use Python, you can use R, or you can also launch an RStudio session and connect and make use of a GPU. If you're using Google Cloud, for instance, another great way of like executing this is just by pulling your Google Cloud account, creating a Google Cloud Compute instance, and running this Docker image. And the great thing here is that, as you can see, we have Arrow already pre-installed. We have SparkLR pre-installed. So you can very easily just connect and do some data processing. If you're running on a real Spark cluster, you probably need to adjust this image to make it work in your particular case. But I think definitely Docker is something that you can consider in your day-to-day. And a few resources. The first one is the Docker image that I was mentioning. You can get it from GITHUB/MLverse. The Spark book and the Spark website are another two great resources. The R Deep Learning with R book is great, or the TensorFlow.rstudio.com site. And if you're into videos, you can also visit us at YouTube. We have a bunch of them on the MLverse YouTube channel, and basically you can just see us live code and why not stuff. All right, well, thank you. And I'll tweet the slides. Yeah.
Thanks, Javier. We have time for maybe 1 or 2 questions at most. Please remember to fill out the survey, but afterwards, by all means, maybe catch Javier, because we have a break from 4 to 4:30.
Thanks for the speak. I just have one quick question. The arrow thingy, do you need to configure that? I just saw that you loaded the library, and then does it work automatically?
Yeah. So when you're using Arrow in your local computer, all you need to do is say install the Arrow library from cron. So you say install.packages Arrow, and it installs from cron, and then you have speedups in SparkLR. So definitely do that. When you're working on a cluster, you do need to ask your system administrator to install Arrow in the entire cluster. So if you go to the Arrow page, they have instructions on how to install the runtime. So that's a bit annoying, but like that's the way it works. So yeah.
Okay, thanks.
Yep.
Thank you very much. Are you planning any deploy of AutoML?
Yeah, interesting. Yeah, so the closest thing I think we have to AutoML today. Well, first of all, you can use. I don't know if do you mean AutoML from H2O or?
No.
Or just in general. So
just in general.
Yeah. Well, yeah. So first of all, H2O comes to mind because you can use H2O with Spark and R with the R sparkling extension, and they have some concept of AutoML. The other extension that we have, which is kind of related with AutoML, is AutoKeras, which is kind of like a competitor. So basically, you can use Keras to automatically train your models, and there's an extension out there. AutoML, it's not on SparkLR yet, but like we should make it available. If you want to open a GitHub issue, please feel free to. If not, I'll go ahead and open it. But,
okay.
Yeah.
Thank you.
All right. Well, thanks, everyone. Please enjoy your break and enjoy the rest of the afternoon.